All right, we're going to finish up on section 7.2 today, operations with decimals. We had looked at addition, subtraction, multiplication, and division, and we also had looked at scientific notation. So we are at the point where we're going to talk about rounding and estimation. All right, so first of all, we're going to look at rounding. So rounding is the one that you're most familiar with. Rounding means that you find the location you're supposed to round to. It says rounding to the nearest blank because anything can kind of fill in the blank. It can be rounding to the nearest tenths place, or it could be rounding to the nearest hundredths place. So things can be very, very rounded, right? Or they can actually be pretty specific. It just depends on what you're rounding to. So you find that location that you're going to round to, and you look at the next value. If the next value is 0 to 4, you round down. And if it's 5 to 9, you round up. We'll do an example of that in a minute. Front-end estimation, however, is slightly different. And front-end estimation is one that often you haven't seen before, but it is used. Front-end estimation, what we do is we take the first value, or the first couple of values. Sometimes we're told to round or to use the front-end estimation with a specific accuracy, and sometimes we're not. And you round off. Round off means round down. So if you want to write down round off, it actually means round down. It means you keep the values that are there and you make everything else zeros. That's what rounding off is. All right, so we're going to do an example. We've got the number 203 and 651 thousandths, and we're asked to round in different ways. So rounding tells you where you're going to round to. This one says 100. 100 is the 2's place. Okay, well, where the 2 is. So the nearest 100 means that we go to the hundredths place and you look at the decimal or to the value right afterwards. So it's a 0. If the number is 0 to 4, we round down. If the number is 5 to 9, we round up. So rounding down doesn't mean that the highlighted 2 changes. That 2 doesn't change when we round down. It stays the same. It's all the other numbers that go down, and they go down to 0. So this number is actually 200. Okay. Now with hundredths, I'll keep using my same piece up here. We are looking at the second location from the right, the tenths place, then the hundredths place, moving toward the right. So we're using that value, and again, it's going to stay either a 5 or it's going to go to a 6. It can't go down to a 4. That's not a thing. It either stays 5 or goes to 6. We look at the number afterwards, and it's a 1. Because it's a 1, first of all, anything after it is zapped out. We don't have anything there. But because it's a 1 and it's in that 0 to 5 range, 0 to 4 range, it goes down. So that 1 will leave it as or will become a 0, and the 5 will stay the same. So I have 203.65. Okay, so again, it doesn't go down to a 4. That's not what we mean by round down. It means all the numbers after it go down to 0. Units place. The units place is the same as the ones place. We talked about that on the first day we talked about decimals. So this is the units place. So with the units place, again, this will stay either 203 or it'll go up to 204. Those are the only options, and we make our decision based on the 6. And what does the 6 tell us to do? It means it tells us to go up. That's the first one we've had that's done that. 5 to 9 range, we're going to go up. So my 203 will become 204. Okay. All right, we're going to see the front-end estimation come into play on example 6. So on example 6, these are like verbatim directions off of some of the problems you're going to be taking a look at. They just tell you to use A, rounding, and B, front-end estimation to estimate the following, and then actually do the problem, like perform the calculation and see how close your estimates are. Here's the problem with this. It doesn't tell you what kind of accuracy. I kind of think that's a problem. But what that does mean is that you get to pick your accuracy. So you get to decide, do you want to do rounding to the tens place, to the units place, to the tenths place? Those are basically your 3 choices. The more decimals you keep, the harder the problem actually innately is. So I'm going to do it in a couple of different ways. We're going to do it to the tens place first, and see what it looks like as far as the differences between doing rounding, that's part A, and doing front-end estimation, that's part B. And then we'll do it to the units place as well, because I think those are the two most natural ways to do this rounding, is either to do the tens or, you know, the whole number parts of it. All right, so for part A, if we're going to round to the tens place, what that means is that we round the original values. It doesn't mean do the work and then round, right? It means round and then do the work, because the whole point in the rounding process is to make the work easier to do. So in 89 and 47 hundredths, the tens place would be the 8. And what would the 9 after it tell me that this 89 and 47 hundredths will become? It'll be 90. Okay, so we've got 90. And then in the second value, we've got a 3 and we've got the 2. So will the 3 become 30, or will the 3 stay at 30, or will it become 40? It'll stay at 30 because the 2 is a small number afterwards, right? It's lower than 4 or lower. And I'm supposed to be subtracting. 90 minus 30 is 60. Okay, so that's rounding. That's what we just did on the previous slide anyway with some other numbers. Front-end estimation looks a little bit different. So if we've chosen to do the tens place with rounding, we're going to do the same tens place with front-end estimation. Front-end estimation simply says that whatever those place values or values are in that place value, in this case the 8 and the 3, you keep that and you zero everything else out. It doesn't matter how close it is to the next value up. You zero everything out. That's front-end estimation. So the 89 and 47 hundredths is 80, and the 32 and 16 hundredths is 30. Now, sometimes it will be the same, right? If this, instead of saying 89 and 47 hundredths, said 84 and 47 hundredths, these two different processes would have yielded the same answer. But sometimes they're also off from each other. All right, so let's do, it doesn't call it part C, but it's part C, right? Then do the following actually out by hand. We'll do part C, and then we're going to actually run back up and just do this with the units place, because we have a little bit of time to do that, so you can just see that if that's what it was telling you to do, or if that's what you chose to do, what it would look like. So for part C, we're going to take 89 and 47 hundredths, and we're going to subtract 32 and 16 hundredths. And we'll start on the far right. 7 minus 6 is, 4 minus 1 is, and then 9 minus 2, and 8 minus 3, 57. All right, so you can see, given the ones we chose to do, by rounding to the tens place and by doing front-end estimation to the tens place, the one that's closer is the rounding option, right? Okay, so I'm going to shrink this just a little bit, and we're going to do it to the do it with the units place, just so you can see what it would look like. So if we did part A rounding, we would, instead of being looking at the 8 and the 3, we would be looking at the 9 and the 2. So the numbers before the shading always stay the same. 89 will either say 89 or it'll go up to 90. So will that 9 stay as it is, or will it go up based on the 4 afterwards? It'll stay the same, so it's 89. On the next one, the 32, based on the numbers afterwards, it will also stay the same. 89 minus 32, not too bad. I have 27. Don't say 27. I have 57. 57. It has been a long day. It's been a really long day. I'm sorry. All right, part B. So with front-end estimation, right, we keep the number that's shaded and anything in front of it, and we zero everything else out. So with front-end estimation, we actually would get the exact same thing on this one, wouldn't we? It would be identical. So in this case, if I used units places, they don't change. It's the same 89 and 32. It doesn't matter. Adelina, you're looking at me like, are you okay?
Is it because we're doing the units place, and so there'd be zeros after the units place?
Yeah.
Front-end estimation?
Yeah, so front-end estimation makes, right, so front-end estimation makes whatever place value you are after that zeroed out.
Okay.
So it's going to zero out the 47 and the 16 that I just highlighted or circled or whatever, but the numbers in front will stay the same. No matter what they were, they just don't change. So we're rounding down or we're rounding off when we're doing front-end estimation. And it just happens to be that when I use actual rounding, they would round down with those particular values as they're done. And you can see a couple of things. First of all, you can see that, these worked out to be the same, whereas with the front-end estimation with the tens place, it didn't work out the same. Sometimes they do, sometimes they don't work out the same. You can also see that on part C, which I'm not going to redo it because it's the same part C, that clearly our answer when I use the units place is going to be a better estimation for the real answer. But the reason for that is not because of how I did it, it's because I went out to more place values. So the more place values I use, the better my estimate's going to be in general anyway. Any question on that? Okay. All right, so grab a calculator if you've got one with you. If not, you might want to take a peek in on somebody else's. We're going to be doing, this is a calculator exercise problem, but it's a very interesting one and maybe a little bit counterintuitive. Okay, so this is a section C kind of problem, the connection section, and it says the following. A student tries to calculate 999 thousandths to the 10,000 on a calculator and finds the answer to be 4.5173346 times 10 to the negative fifth. Okay, so that's a very small number. We just talked about scientific notation. If we were to change this and we were to put this in scientific form, we'd move the decimal point 5 places to make the number very small. This is a very small number. So the student wonders how it is that you could have a number that's 0.999, so close to 1, and you can raise it to a power and you end up with a result that's almost 0. How do you respond? So we're going to actually do a little bit of some calculator stuff to see how this works out and why it's happening this way, and then we'll talk about it in general. So the first thing we're going to do is we're going to take that 0.999 and we're just going to multiply it by itself. So we're going to square it, okay? And as we're working together with your calculator, I'm just going to use 6 decimal places to estimate everything just so that we're being consistent throughout the process. So I'm just always going to use 6. So if we take 0.999 squared, you should get 0.998001, do you? So everybody who has a calculator and doing it, does that work out? Okay. And I don't want to do like cubed and then to the power 4 and to the power 5 because that's going to move things too slowly. So what we're going to do is we're going to, hang on, let me shift this to the side. We're going to consider that we're doing this. Then we're going to square again. Now, if you have a TI 89 or TI 83 or 84, I can tell you that you can actually just hit the square button and press enter and it will square it again. What we're going to do, what we're really doing is we're taking that 0.999 squared and we're squaring it again. So we're going to the power of 4. That's what we're doing when we square it again. And the result that my calculator just gave me was 996006. Okay, so if you're working in your calculator and you squared it again, did that work? Did you get this result?
What do you press?
Just the square button, like the button that looks like a little square. It should take the previous answer, square it, and you can press enter. Did that work, Kaylee? Great. Okay, so we're going to keep doing this process where we keep squaring the previous answer. I'm going to write down what it's actually doing on the left, but your calculator is just going to give you an approximation for it by hitting enter. You can actually just press enter right now. You don't even have to press squaring again. You can just press enter and it'll do it again. And it would give you 9920080 actually. Oh, sorry, I missed a decimal. 028. There we go. Missed a number. So if I square it again, that was actually to the power of 8, because 4 squared, not 4 squared, but 4 times 2 gives me an 8 when I square it. If I square again, it's in essence multiplying that power by 2 again, so I have a 16th. If I press enter, my calculator will do that again. 0.9844, 4119. Okay, so pause here for a moment. What do you notice about the numbers? They're getting smaller, but it's not happening fast, right? I mean, they're minusculely smaller, right? So right now, this is the first one, this is power 16, where it's not 0.99, right? I mean, it's 0.98, and it's almost 0.99. It's like it's not far off. Like, they're getting smaller, but it's not happening very quickly. Agreed? Okay, we're going to keep doing this several times more. So we're going to press enter again, which would be to the power of 32. Every time I do this, I'm just multiplying my exponent's power by 2, so you can see what will happen. And I have actually taken the biggest jump away that I've done so far. 968, 491. Yes.
Why are we doing this?
Because we're trying to justify why this is happening. Why in the world, when I have a number that's almost 1 and I raise it to a power, should it become 0? Because that seems a little weird. It does, right? I mean, like, it's pretty much 1. And if I raise 1 to any power, it stays 1. So how is it that I'm raising something that's pretty much 1 to a power and I'm getting back nothing or almost nothing? It's very odd kind of a result. And so we're going to see how it happens with some increasing some powers along the way.
Okay, I understand.
Yeah. Okay, everybody good? Okay, so we're going to keep going a few more steps. I'm going to run out of space and I'm going to go to another screen, but I've got a space for a couple more. So instead of 32, again, I'm going to double it. So I'm going to do 64. .937975. Ooh, that's a bigger jump, wasn't it? If you think in terms of money, I just went down from 97 cents to 94 cents. It's bigger than the jumps before. We'll do one more on this screen. 64, 128, doubling the exponent each time. And lo and behold, what happened? I crossed the 0.9 mark, right? Okay, so we're going to do it, I think it's just a couple more times, 3 more times maybe. Okay, so if I double the 128, what's 128 doubled? You know? 256, yeah. And it went down a lot, at least compared to the other ones that I've done. So we've got a 10-cent drop. If your gas dropped 10 cents, you'd be happy, right? For sure. 10 cents. It's a big drop, right, compared to what I've seen, for sure. Let's do a couple more. What happens if I double, like, what is double 256? 512. And what does it give us? 599142. Yep. And we'll do it one more time. And then we're going to stop. This doubles to 1024. So we're like 1/10 of the way there. 1024 is 1/10-ish of the 10,000. I'm supposed to be raising it to the 10,000 over here, right? Raise to the 10,000, and here I'm actually raising it to the 1,000 approximately. And when I do so, I have 358,971. Okay, so it's plummeting, and it's plummeting much, much faster with every sort of pressing of enter on my calculator, doubling the power as I go, those kinds of ideas. So what's actually happening here? Well, when you multiply by a value, I should probably say a positive value because that's what we're looking at, a positive value less than 1. That's what I'm doing every time I'm multiplying by 0.999 or something else that's even smaller than that, right? I'm multiplying by something smaller than 1. Your product becomes smaller. And here, that is in this problem, we are doing this. That is the multiplying by something less than 1. So multiplying by a value less than 1. $10,000 times. We showed out at least interim steps to get to about 1,000, and we saw it go down pretty drastically. And it's going to keep jumping down just like that if you continue. Press a couple of equals times more on your calculator and you can see it. I mean, 2 more times and I'm at 0.01. That's all it took. So it happens pretty quickly after we get going in the process. At the beginning, it's really slow because we're not doing it by something very much less than 1, but it gets to be multiplying by values less than 1, more than that, as you go. Okay? So it's a very strange phenomenon. Yes, we do have something that's nearly 1. Yes, we are raising it to a value that's very large. And yet, because when we multiply by something less than 1, it gets smaller, this will end up plummeting to 0.